You may have come across a word pseudo force. Pseudo is unreal, right? What could be unreal about a force? Forces are exerted by, say, somebody and somebody. Weight is the name given to the force exerted by the earth on a body. There is an agent, earth, and an object which is experiencing that force. There is an A and a B. Force is exerted by A and B, and of course there will be a reaction on A due to B. Forces happen in pairs, right? So what would be a pseudo force? What would be unreal about a force? Let's imagine doing an experiment like this. We have a truck with, say, it's all closed inside, and this is moving, say, this way. And we have this is a smooth surface here, and we have a block lying on that smooth surface. We fixed a camera here to watch what happens inside the truck. That is, what we watch here would be the motion of the object related to the truck. If the truck is moving, the camera would see this block as at rest because it is also moving along with the block. So we are watching the motion of objects inside the truck with reference to the truck, in the reference frame of the truck. Suppose brakes are applied on the truck. What would you say? Well, the floor of the truck slows down, but the block was originally moving with a velocity v to the right, the same velocity as that of the truck, and it continues to move and hit the front end of the truck. But what would the camera see? It would see the block at rest and starting to move. If something at rest starts moving, what would you say? An object cannot move on its own, right? That's inertia. So if you are trying to analyze the motion related to this camera, you would say the block, for some unknown reason, moved. Ground observer has a simple explanation. The block moved due to inertia, but the observer inside the truck, with reference to the truck, remember, truck is accelerating, it's slowing down, so you have an accelerating reference frame here. So you have well, something unusual happening here. An object at rest starts moving. Imagine this happening in the room you are sitting in. There is an object on the floor some distance away from you, and it starts moving one way or the other. You would say something unusual. But one thing you would say is, since objects cannot move on their own, there must be some force that must be acting on the body to cause that motion. I do not know the agent for the force. I do not know who is exerting the force, but there must be a force acting on the object which started moving. That's what you would say here. The object was at rest with respect to the camera, and it started moving. So there must be some force that you need to imagine to explain that behavior. So you imagine that force to explain the behavior. You do not know what the agent is, who the agent is. So that's the pseudo force here. So you have a force which is necessary to be imagined to explain a behavior. Now this force is imagined in accelerating reference frames, right? You should know that Newton's laws are not valid in accelerating reference frames. They are valid in inertial reference frames. But just imagine somebody has learned the laws of motion, and he knows that an object at rest cannot move on its own, and he sees this happening. The camera sees the block at rest. Mind you, the camera doesn't notice the truck's motion, truck's deceleration. No. The block at rest started moving. Or imagine, well, there was a pendulum hanging from the ceiling. As long as the truck is moving with uniform velocity, this string would be vertical. But when the truck starts decelerating, imagine this deceleration takes a while. They'll start swinging. It will swing, and due to resistance where it eventually slows down and comes to a position like this. Now, if you see a string with a stone attached in a room, not staying vertical and it's at an angle, you would say there is something crazy here, something funny happening here. How do I explain that? You need to imagine a force to explain this behavior. There is force mg here, there is force T here, and this staying at an angle because of some unknown force acting to the right. In fact, this force comes out to be mass of the body times the acceleration of the reference frame, but in the opposite direction to the acceleration. Now, if the truck is going this way and is slowing down, the acceleration is this way. So, in this reference frame, a force is necessary to be imagined to the right, and the magnitude of the force is ma. So, that's the pseudo force. In accelerating reference frames, you need to imagine a force to explain the behavior of objects in that reference frame. If the ground observer sees, if an inertial observer sees the reference frame accelerating at A, he needs to imagine a force ma in a direction opposite to the acceleration of the reference frame to explain the behavior of objects in the reference frame. Mind you, this is, well, an explanation. This is the force required to be imagined in the accelerating reference frame. The acceleration of the reference frame with reference to the reference frame itself would be obviously zero, right? So we have to know the acceleration of the reference frame as seen by an observer outside, an inertial observer, and then use that value of acceleration and to explain the behavior of objects in the reference frame, you imagine that force. That's it. Another very familiar thing you know is about, well, acceleration due to circular motion. If this truck were to take a circular turn, traveling with a uniform speed but taking a circular turn, this pendulum would swing sideways. It would oscillate a bit and come to rest. It would be sideways. Now again, that cannot be explained in terms of, well, what is happening inside the truck. The ground observer would say it stays at an angle because, well, there is a tension T here, there is tension T here, there is mg here, and when it has eventually come to rest, the resultant of these two will be equal to mr omega squared. This the acceleration that's required. There's no force here. There's an acceleration here along with the truck. But the observer inside the truck doesn't see that. Or in the truck is not going around a circular path. Truck is at rest. So this force. But then imagine initially what that sideways motion the truck observer in the truck would say. He says this is staying sideways because there is a force acting sideways. For him, this is the situation. There is a force acting sideways, and its value is mr omega squared for him. That is the acceleration of this object as seen by ground observer is r omega squared, and this observer inside the truck has to imagine this force. Well, so that's what you call centrifugal force. Centrifugal force is not real, right? So it's an imaginary force. It's imagined in the rotating reference frame by an observer who needs to explain that sideways motion. That's it. That is pseudo force. For any force, you should be able to identify the agent. Who is exerting the force? Who is experiencing, you would know, but who is exerting? The object which is at rest, if it starts moving, it is experiencing that force. But who is exerting the force? That agent you cannot identify in accelerating the reference frames. So we need to imagine an agent. We need to imagine a force without an agent. That's what is unreal about it.